Please note at the end of the last video when we were solving this, it looks like this is really not 5. It looks like this is much closer to 6. Okie doke. But let's move on. Interval notation. This is likely new for most of you, but what's probably not new for you is simple inequality notation. So this is kind of like a chart that's got everything you need on it, but generally let's move right to the examples. I don't want you to skip this chart. It's really important for you to look at this chart, but we'll let it go. I'll maybe say this, that this notation right here, it's not that important, but it reads as the set of all x such that, so this line right here reads such that x is between a and b. But don't let some of these notations bother you. I want you to start seeing math notationally because that's an important part of math, to be able to read the notation. So I can pick up a Korean math textbook and read it just like I can read, a Spanish math textbook. So math reads the same in any language, and that's why the notation's important. But most of it's just exposure, so don't let it worry you. But please do ask questions if you have it. But for right now, let's get to examples, because you should look at the chart on your own. But I'm going to go to the examples so that it makes the most amount of sense for you. So you should be familiar with all of these and all of these. Let's look at a couple and write them in interval notation. X strictly greater than 3 means it's all the values of x. So if we were going to write this with a number line, it's all the values of x greater than 3. So you guys probably did this. That's an open circle, and you do this. So with interval notation, we say open circle by doing circular brackets, and we say from 3 to infinity, and infinity always uses circular brackets because you never quite get there. Let's look at this one. X less than or equal to -2. That means we're going all the way from negative infinity. We're going to use circular brackets all the way up to -2, but this time we're going to include -2. So we're going to give it a box so that the 2 doesn't fall out of there. Here, we're going from 3 to 5 inclusive, so we're going to say 3 does not get included, but 5 does get included. So let's try this example. Here, we're going from negative infinity all the way up to -4, but we don't want to include -4. And then if you want to, we can use this U for union, meaning or. It's really like an or statement. We're going to start again at +4 and go all the way to infinity. Oops. So I'm going to do 2 more examples of this for you. Oops. So here we want the entire number line. Oh, we can say that by saying negative infinity to infinity. Here we want every number except for 1. So we can say from negative infinity all the way up to 2, but we're not going to include 2 because there's an open circle. And then we're going to say start again on the other side of 2 and go all the way to infinity. There's a lot of practice here. I will leave that up for you to look at, and look at the key online and ask me in class or via Zoom if you have questions with that. Ditto here. I'm going to leave the solving for you. Recall that the only difference between solving inequalities and equalities is that if you multiply by a negative number, you need to flip the signs. So I'll leave those for you to take a look at. Domain and range. All the possible input values, range all the possible output values. So we could have a function defined in terms of sets. You maybe saw this before. I'm not so concerned about this right now, but the domain is just the input values. Let's see, I'm going to put them in order, and I'm going to write it with this little bracket set notation. I'm going to say -2, -1, 1. Oh, I'm not going to repeat the 1 because we don't want to do that. And let's see, what are our output values? We've got -2, 0, 2, 3. What we do know is that this is not a function. And it's not a function because for a function, there's only one output value for each input value. But here, we have the input value of 1 basically going to 2 different output values. That's not a function. If we were to graph that, where the input of 1 goes to both 3 and -2, we'd see that it would create a vertical line. So sometimes this idea, which is the better idea, is shortcutted, and we call it the VLT, vertical line test. There are some drawbacks to this vertical line test that we will look at next unit. But that's they're the same thing. If you have an output, one output going to 2, one input going to 2 different outputs, that means that somehow you can put a vertical line through your function, and that makes it not a function. So here's some examples. Let's look at this one really quickly. If we look at this, what's the domain? Oh, there's only 2 numbers in the domain. It's -3 and 2. And the range, oh my gosh, the range is about what y values this thing covers. Well, we can see it covers all the y values. And to say all the y values, we say -infinity to infinity. Is it a function? No way. We can see here and here that one input value goes to not just 2 output values, but an infinite number of output values. Let's take a look at this circle because we'll be doing these next unit. So what's the domain of this? Well, let's see. It's all the x values. So the domain is all the possible x values. It looks like the smallest possible x value is -2, and it's everything between -2 and again at 2. So that means we want to include -2 all the way up to 2, including 2. The range, that's the y values. So if we take a slider and look at all the y values, there we're going from 1 to 5. Is it a function? No. And here's your quick way if you're given a graph of something called an explicit function. So if it's an f of x function, we can say, oh, because we can look at a vertical line and it hits twice. No. So the VLT says, no, look at that. There's 2 outputs for this one input of 1. And Again, I know I'm leaving a lot for you to do, but there's a key online. So please, as you do this, look at the key and ask me questions as you go through. We're at 10 minutes, so I will do a little bit of this, but I might have to pull through one more video. So when we talked about y equals y naught plus slope x minus x naught, I mentioned we can call that translation form. And indeed, that's what we're going to look at right now, the translation of functions. So what a translation does is sometimes it's called a slide. So all you're doing is taking something and you're moving it and it remains congruent. Remember that word we looked at before? So they stay the same size and the same shape. So all we're doing is taking it and sliding it. And here's how this form slides a function. It takes each and every xy value and moves it x naught, y naught. So minus x naught moves it to the right x naught. Y naught moves it up y naught. So let's look at this. This piece says move it up 3. This piece says move it to the right 2. It also says take any xy point on the object and move it to x plus 2, y plus 3. So to move this thing, we say, oh, we're going to go take every point, move it 2 to the right, and up 3. So that point got slid right up there. 2 to the right, up 3. We slide that. 2 to the right, up 3. There's our slide. 2 to the right, up 3. And 2 to the right, up 3. This is our transformed object. So on this question, I'll leave it up for you, but I did want to talk about this briefly. This is really about lesson 1.4, but I just wanted to bring it up here in that this negative sign affects the output value. So one of the things that you can think about is if it's inside the parens, it affects the input value. So this affects the output value, and all it's doing is making the output value negative. So I'm going to tell you the transformation of j of x equals negative f of x is j of x takes every xy point and turns it into x comma negative y. I'll let you graph that and see if you can think about what does that look like. So maybe make an observation. And we'll stop it right there, and we will hopefully get through the rest in one more video.